Yes, now we are going to see about a high-speed sample and hold circuit. So here the sample and hold circuit diagram is shown in this figure. So where we have two operational amplifiers which are named as A1 and A2 respectively, and we have one FET which is going to act as a switch. Okay, so this is a MOS type of FET or the transistor, and it is going to act as an analog switch as I told you. So such as that from a TTL. So it alternatively connects and disconnects. So the switch is just going to perform the function of just an on and off operation. So when it is on or when it is, say for example, if it is closed, we say it is connected to the capacitor, or when it is open, it is not being connected. So the diodes, there are two diodes which are D1 and D2. They are inverse parallel connected, and they are going to prevent the op-amp A1 from getting into saturation when the transistor N is off. So this operation of the circuit is this makes the circuit to perform faster, and the output of the op-amp A1 will be given by the equation as V naught dash with respect to the time t is equal to Vi of t minus 0.7 ohm. So this is the state when we have the input voltage is less than V naught of t. Supposing if it is going to be greater than that of V naught of t, then we have V naught dash of t is equal to Vi of t plus 0.7 volt. So that is the difference. So this is going to reduce the output voltage. So when the transistor M, so transistor here meant as the MOS type of transistor, so that is we call it as an analog switch. So when that is on, the op amps A1 and A2 are going to act as an voltage followers. So how the waveform is going to be given for the circuit is, so this is the signal voltage and this is the FET control voltage, and this is how the capacitor voltage happens for the output voltage value. So the transistor M, as I told you, it is going to be switched on and off, and it has been closed or open. So it is done by a control voltage, and that control voltage is given a name called Vs. So that is given at its gate terminal. So we all know a FET has got three terminals: the source, drain, and the gate. So at the gate, we apply this control voltage Vs. So this is going to control the on and off operation of the switch. So note that this voltage is supposed to be higher than that of the threshold voltage of a normal FET. So when the transistor switch is on for a short interval of time, the capacitor will charge or discharge to a value of the analog signal at that instant. So this is the analog signal voltage. So it is set to charge or discharge based upon this analog signal. So otherwise it is when Vi is larger than the capacitor voltage is named as Vc, and the transistor N is off, it will rapidly charge to a level that is called as Vi in the instant EM switches on. Similarly, if Vc, that is the capacitor voltage, is initially greater than Vi, then C1 will rapidly discharge to the level when M becomes on. That is, M here is the MOSFET or the MOS transistor we call. So when M is off, only the input bias current of op-amp A2, that is, this is op-amp A2, and the gate source reverse leakage current of the FET are effective in discharging the capacitor. So hence the sampled voltage is held constant by C1 until the next sampling instant or acquisition time. And this is how sampling or acquisition time T1 and the holding time T2 is defined. So this is the acquisition time, which is supposed to be the rise of the curve, and this is the holding time, that is when the voltage value is held for a certain period of time. So that is given as T1 for the acquisition time and T2 for the holding time respectively. So during the sampling time, C1 is getting charged. So this charging is done through the FET channel resistance, which is RDS. and the charging time T1 is equal to 5 into RDS of condition of the FET and C1 when the capacitor charges to 0.993 of the input voltage. So during the hold time the capacitor will partially discharges, and this is called as the hold mode droop. Okay, so when the during this holding time, this hold mode droop happens when the capacitor partially discharges. So in order to avoid this hold mode droop, the op-amp A2 must have a very low input bias current, that is the capacitor should have a low leakage dielectric, and the MOS transistor must have very low reverse leakage current between its gate and the source terminals. The low channel resistance is desirable for the FET to achieve faster charging and discharging of the C1. So this is how we are able to overcome the hold mode droop, and we can achieve a better sampling as well as a holding circuit. That's all. Thank you.